ionic compounds are made up of metal cations and non-metal anions. We can predict the formula for an ionic compound because all ionic compounds are neutral, and therefore we need to only figure out the number of metal cations that is appropriate with the number of non-metal anions so that the charges add to 0 and the compound is neutral. To predict the formulas for simple ionic compounds made up of a metal cation and a non-metal anion, we need to remember that group 1 metals make positive 1 cations, group 2 metals make positive 2 cations, and that group 17 makes negative 1 anions, and group 16 makes minus 2 anions. Thus, if we combine lithium, which is from group 1, with chlorine, which is from group 17, we know that the lithium will be charged positive 1 and the chlorine will be charged negative 1. In order to make a neutral compound, we need 1 positive charge and 1 negative charge to add up to 0, and so we need 1 lithium and 1 chlorine. However, if we decide we are going to make a compound from magnesium, which is in group 2, and chlorine, which is in group 17, the magnesium will have a plus 2 charge in this compound because it's in group 2, and the chlorine will still have a minus 1 charge. Therefore, if we're going to make a neutral compound, I'm going to need 2 chlorines to give me 2 negative charges to balance the 2 positive charges that the 1 magnesium has. Therefore, the formula for magnesium chloride is 1 magnesium and 2 chlorines. To indicate that we have 2 chlorine atoms, we put a subscript 2 after the chlorine. Using this same logic, we can predict the formula for any ionic compound between a metal and a non-metal. So for instance, let's say we wanted to make a compound from aluminum and oxygen. So oxygen is in group 16, so it's going to have a minus 2 charge. Aluminum, which is in group 13, is going to have a plus 3 charge. So to make a neutral compound, we have to find some common divisors that will allow us to combine the right number of aluminums that are 3 plus with the right number of oxygens that are 2 minus in order to get a neutral compound. So if I use 3 oxygens, 3 times minus 2 is minus 6. And if I use 2 aluminums, 2 times plus 3 is equal to plus 6. Then I will have the same number of positive charges as I have negative charges. And so I would write the formula for aluminum oxide as Al2 because I need 2 aluminums to give me plus 6, O3, subscript 3, because I need 3 oxygens to give me minus 6. This will be a neutral compound, and that is the formula for the compound made from aluminum and oxygen. If we want to make a compound from one of the transition metals with a nonmetal, we're going to need to be told what the charge on the transition metal is. Recall that the charges for transition metals are variable and they can take on multiple different charges. So for instance, I might have a chromium 2+ with chlorine, in which case the neutral compound would be chromium with 2 chlorines. But chromium could also have a 3+ charge, so I might have chromium 3+ with chlorine, and then the formula would be chromium Cl3, because I need 3 chlorines 3 negative charges to balance the positive 3 charge on this chromium. Chromium Cl2 and chromium Cl3 are both known compounds, and they are different from one another and have very different properties. In addition to anions of nonmetal atoms, we can also have polyatomic ions. Poly meaning many atoms. So here is a list of common polyatomic anions. Acetate has carbons, hydrogens, and oxygens. Carbonate has just carbon and 3 oxygens. Hydrogen carbonate, so forth and so on. These anions can also make ionic compounds with a metal. So again, to figure out the formula of a metal plus a polyatomic ion, which is always made up of all nonmetals, we look at the charge on the anion and we add the number of metal ions needed to neutralize that charge. So for instance, if I wanted to make sodium acetate, sodium is in group 1, so it's +1. Acetate, according to my chart of polyatomic anions, has a -1 charge, so it's CH3COO-. So if I put these two things together, in order to get a neutral compound, I need 1 positive and 1 negative, so I need 1 of each. So my sodium acetate would be 1 sodium and 1 acetate. This makes a neutral compound. If, on the other hand, I wanted to make a compound between sodium and carbonate, then I would have sodium, and I would need 2 of those with 1 carbonate, because the carbonate has a -2 charge and the sodium has a +1 charge, and so I need 2 +1 charges to balance the -2 charge of the carbonate. And so I would write sodium carbonate like this. You should familiarize yourself with the common polyatomic ions shown in this chart. In addition, you should be able to predict the charge on any nonmetal ion and any metal ion. And using those two things, write the neutral formula for any ionic compound made between either a metal and a nonmetal atom, or a metal cation and a polyatomic anion. Likewise, given a compound, you should be able to recognize whether it is ionic or covalent, remembering that compounds that are ionic always have a metal and some nonmetals.